Hello dear friends, in this video we'll discuss another type of realization, that is FIR filter realization. The question given is h of n is equal to 1 by 2 whole raised to n into u of n minus u of n minus 4. We know that u of n is a step function and u of n minus 4 is another step function which starts from n is equal to 4. Since it is minus u of n minus 4, this u of n minus 4 will come to the denominator, and when subtraction is applied here, only 3 signals remain. That is u of n minus u of n minus 4. We have given 1 by 2 whole raised to n. When this signal is multiplied by 1 by 2 whole raised to n, where n tends from 0, 1, 2, 3, when n is 0, we get 1 by 2 whole raised to 0 as 1. When n is 1, we get 1 by 2 whole raised to 1 as 1 by 2. When n is equal to 2, we get 1 by 4. And when n is equal to 3, we get 1 by 8. Hence, we have to plot the DIR form for this filter, for these signals. H of n is equal to delta of n plus 1 by 2 delta of n minus 1 plus 1 by 4 delta of n minus 2 plus 1 by 8 delta of n minus 3, where delta means impulse function. Taking the z transform of this equation, we get h of z is equal to 1 plus 1 by 2 z raised to minus 1 plus 1 by 4 z raised to minus 2 plus 1 by 8 z raised to minus 3. We know that h of z is equal to y of z by x of z. X of z will be in the denominator. When x of z is sent to the RHS part, we get h of z into 1, x of z into 1 plus 1 by 2 x of z into z inverse plus 1 by 4 x of z z raised to minus 2 plus 1 by 8 x of z into z raised to minus 3. By taking the inverse z transform for this function, we get y of n is equal to x of n plus 1 by 2 x of n minus 1 plus 1 by 4 x of n minus 2 plus 1 by 8 x of n minus 3. We have to plot the DIR form for this equation y of z. Let us plot the block diagram for this equation. Y of n is equal to x of n plus 1 by 2 x of n minus 1 plus 1 by 4 x of n minus 2 plus 1 by 8 x of n minus 3. Unlike IR realization, we don't have a numerator and denominator separately. There is only one equation. Hence, the diagram is a bit different. Here we maximum delay elements is 3. Hence, 3 delay elements are taken in series. There is a constant x of n. Hence, this constant 1 will be here. X of n minus 1 has a coefficient of 1 by 2. This will be 1 by 2. X of n minus 2 has coefficient 1 by 4. And x of n minus 3 has coefficient 1 by 8. And this together forms the output y of n. Let us take another numerical where h of n is equal to the impulse response are given with particular delays. We have to take the z transform of this equation. H of z is equal to, this is impulse response delta of n. We know that the magnitude of this equation of this function is 1 minus 1 by 4. This the magnitude is 1, and since there is n minus 1, we write it as z raised to minus 1, 1 by 2 z raised to minus 2, 1 by 2 z raised to minus 3, minus 1 by 4 z raised to minus 4 plus z raised to minus 5. There is no coefficient term for delta, hence z raised to minus 5 is written directly. We know that h of z is equal to y of z divided by x of z. Sending the x of z to the numerator on the RHS, we get y of z is equal to x of z minus 1 by 4 x of z z inverse plus 1 by 2 x of z z raised to minus 2 plus 1 by 2 x of z into z raised to minus 3 minus 1 by 4 x of z into z raised to minus 4 plus x of z z raised to minus 5. Taking the inverse z transform of this equation, we get y of n is equal to, since x of z is there, we write it as x of n. Wherever x of z is there, we write x of n, and z raised to minus z raised to whatever the power is there, it will be the delay for the function. Similarly, x of n minus 1, x of n minus 2, x of n minus 3, x of n minus 4, and x of n minus 5 with the respective coefficients. We can see that the delay element x of n minus 1 has coefficient of minus 1 by 4 and x of n minus 4 has coefficient of minus 1 by 4. Hence we take it as common to reduce the delay elements, and 1 by 2 and 1 by 2 are also common. Hence we take the common elements and update the equation. Our equation is y of n is equal to x of n minus 1 by 4 into x of n minus 1 plus x of n minus 4 plus 1 by 2 x of n minus 2 plus x of n minus 3 plus x of n minus 5. We can see that the highest delay element is minus 5. Hence, let us draw the delay elements in series. This is our input x of n. We have one term x of n. Let us take it. And x of n minus 1 and x of n minus 4 have common coefficient minus 1 by 4. This is our output x of n minus 1. The output after this delay element is x of n minus 1. The output after this delay element is x of n minus 2. Here x of n minus 3, x of n minus 4, and x of n minus 5. We have x of n minus 1 and x of n minus 4 as coefficient minus 1 by 4. Hence this will be, and x of n minus 1 and x of n minus 4 together sum up with coefficient minus 1 by 4. Similarly, x of n minus 2 and x of n minus 3 have coefficient 1 by 2. X of n minus 2 and x of n minus 3 sum up together with coefficient plus 1 by 2, and x of n minus 5 has coefficient 1. Here we get the second term minus 1 by 4, and here we get the third term 1 by 2. Remaining is x of n minus 5 and x of n. This will be the common point for x of n and x of n minus 5. These together meet to form y of n. We have another numerical where h of n is given as delta of n plus 1 by 4 delta of n minus 1 minus 1 by 8 delta of n minus 2 plus 1 by 4 delta of n minus 3 plus delta of n minus 4. By taking the z transform of this equation, we get h of z is equal to 1 plus 1 by 4. Since n minus 1 is there, it becomes z raised to minus 1. N minus 2 is there, z raised to minus 2. Similarly, z raised to minus 3 and z raised to minus 4 with the respective coefficients. We know that h of z is equal to y of z divided by x of z. When x of z is sent to the RHS, we get y of z is equal to x of z plus 1 by 4 x of z z inverse minus 1 by 8 x of z into z raised to minus 2 plus 1 by 4 x of z into z raised to minus 3 plus x of z into z raised to minus 4. Taking the inverse z transform of this equation, of this y of z equation, we get y of n is equal to x of n plus 1 by 4 x of n minus 1 minus 1 by 8 x of n minus 2 plus 1 by 4 x of n minus 3 plus x of n minus 4. We can see that x of n minus 1 and x of n minus 3 have common coefficients 1 by 4. By taking the coefficients 1 by 4 common, we get the updated transfer function, and for the transfer function the block diagram is drawn. We have the equation y of n is equal to x of n plus 1 by 4 x of n minus 1 plus x of n minus 3 minus 1 by 8 x of n minus 2 plus x of n minus 4. We can see that these two terms have common coefficient 1 by 4 and this has coefficient 1 by 8. The total delay elements are up till n minus 4. Let us draw the delay elements in series. We know that the output of this delay element will be x of n minus 4. When x of n is the input, The output of this real element will be x of n minus 1. Output of this will be x of n minus 2. Similarly, x of n minus 3 and x of n minus 4. We have x of n with coefficient 1 and this term has coefficient 1. Let us draw this x of n minus 4. These two terms x of n minus 1 and x of n minus 3 have coefficient of 1 by 4. This is our x of n minus 1 and this is x of n minus 2. They together have a coefficient of 1 by 4 and x of n minus 2 has coefficient of minus 1 by 8. And this together sums up to form y of n.